All right, welcome back to pre-calculus. Today we are going to continue talking about sines and cosines and how to graph them. Okay, let me go ahead and share. All right, so we can have our discussion here. All right, so they want to know, okay, which intervals 0 to 2 pi, non-inclusive, which means we're not going to include the endpoints. Is the graph y equal to cosine x increasing? And since it's a part 1 of 2, I'll bet where it's going to be decreasing as well. Okay, so let's go ahead and take a look at that. Okay, we've shared, we're good. All right, what's cosine look like? All right, so here's how you graph this thing by hand. All right, we go from 0 to 2 pi. Okay, any length you want to pick, call that 2 pi. Okay, halfway through, okay, we're going to call that pi. Half of a half, we're going to call that pi over 2. And then halfway between the second region here, we're going to call that 3 pi over 2. Almost every graph I make is going to start off like this. Okay, we have -1, +1. Okay, so this is y is equal to cosine. So we're going to be up here. Okay, pi over 2, right? That's vertical distance, or horizontal. We're measuring horizontal distance. There is no horizontal distance at 90 degrees. At pi, right? If we come across here, we have -1 as a horizontal distance. Okay. At pi over 2, again, horizontal distance is back to 0. And then all the way back around, we have a horizontal distance of 1. Okay, and then we connect the dots. And there we go. Okay, so it wants to know, where is it increasing, where is it decreasing? Okay, anytime, like pretend you have a little skier on your graph here, anytime this is going to be work, that's where it's increasing. Okay, so if I extend this way, I know the rules say I don't have to, but if we did, right, this would be work here too. Okay, so even though the arrow is pointing down, it doesn't matter. We read it from left to right. As we're going from left to right, this guy is climbing uphill. Therefore, right, it is an increasing graph. So increasing is going to be between pi and 2 pi. Okay, one of the reasons they don't include the endpoints is because here, right, it's kind of flat. And is that increasing or decreasing? And we just don't want to make a decision. So we just say, well, we don't include the endpoints. We don't include the point where it's flat. Okay. Same thing right here. And same thing right here. Okay. So decreasing, this is where it's fun to be a skier, right? So anytime where it's fun to be the skier, so even over here, right, it would be a decreasing function. Okay. So this would be a decreasing function between 0 and pi. And they only wanted to know for one waveform, so we're just going to go from 0 to 2 pi. So this stuff over here doesn't count. We don't care. This stuff over here doesn't count. For this problem, we don't care. Okay, so that's my increasing and decreasing. Let's see what they asked. Okay, where is it increasing? It is increasing between pi and 2 pi. 2 pi. All right, on the empty boxes. Oh, they do. Where's it decreasing? Okay, so this is going to be from 0 to pi. All right, so there's our spots. All right. Okay, identify the amplitude of the function. Okay, I can get into this now. All right. So amplitude this is the easiest question somebody's going to ask you. Okay, just take the absolute value of the number that's in front. Okay, 5. Okay, that's it. That really is it. Okay. All right, amplitude here, 1/5. Okay, and if it's negative, we don't care. We take the absolute value, we move on. Okay, that's still the amplitude. Okay. Boy, they're having a day today. All right, there we go. See, negative, doesn't matter, still 5. Okay, and there we go. All right, so whatever number is out front, that's the amplitude. If it's a negative number, we strip the negative off and make it positive. So we just take the absolute value of whatever number happens to be in front. Okay, all right. So let's go ahead and move on. I promise they get harder. Okay, so graph the function, identify key points from one full period. Okay, what do they mean by okay? What they mean, I'm going to assume they mean the same thing I mean, is we have y is equal to 1/3 cosine x. Okay, so what we're going to do is we're going to type in our graph here. We go from 0 to 2 pi. Halfway through, there's pi, half of a half, pi over 2, and halfway between these two, 3 pi over 2. Okay, it's still cosine. Okay, so what we want to do is go down, down, up, up. We're going to be at 1/3. We're going to be at negative 1/3, and we should be set. All right. So what I mean by key points, I think they mean these points here. Okay, it'd be our min, our maxes, and our intercepts. Okay. So that's exactly, if I ask you a question to graph something for me, this is exactly the way I'm going to do it. All right. So let's go ahead and plot our points here. So we are going to have x equals 0, y is equal to, not 1, 1/3. Okay, plot that point. Okay, x is equal to pi over 2. Can we do pi? No, we want this pi. So pi over 2 and 0. Okay, plot the point. Okay, next one, we're going to be at pi. Okay, and it's going to be at negative 1/3. Okay, and they really do want you to use the fraction. They don't like it when you use like 0.333. They really don't like that. So we have 3 over 2 pi, 3 pi over 2, and we are back at 0, plot the point. And then we have 2 pi, and our max value again is 1/3. All right, plot point. And that should give us some values there. How do I get out of this? Nope, only empty boxes. We'll say no, I don't want that. We'll say 2 pi, and 1/3. Okay, plot the point. All right, now I don't like that they did this to us. Really? Plot a point anywhere. We did. I don't know how to get out of this. Graph the function. Okay, let's hope for the best. Okay, I don't know how to not do that for the thing when they put the little sign up there. I think technically you guys should have another one, or another little thing where it says get out of this box, but I don't know if it does. And I've not been able to find it. And it doesn't happen on every problem. Okay. But let's try this one. Okay. So we have y is equal to -3 cosine x. Okay, so again, all the graphs look the same. 0, 2 pi. Okay, here's pi over 2, and 3 pi over 2. So we have 1, 2, 3, 1, 2, 3. So what I'm going to do, because there's a negative here, is I'm going to go ahead and dot this in first, and then I'm going to turn it upside down. Okay, so this would be dotting this in. Okay, try to make it look a little bit better. And then when I'm looking to actually graph this thing, I'm going to think about this upside down. So we're here, 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 and here. Okay. And then let's see what this is going to look like. So it's going to look like this. All right. And then we'll keep going. Okay, this is not the end of the story. It doesn't look like a parabola. Okay, we end up with something like that. Okay, so let's see if we can do it this way instead. So grab our pen. We go from here, pi over 2, we're at 0. At pi, we are at -3. 3 pi over 2, we're back at 0. And then 2 pi, we are back at -3 here. Okay, put that in there. Okay, and we'll hope for the best. All right, there we're happy. Good. All right. Sine of 2x. Oh, now they're getting fancy. Okay, now they're changing the period on us. Okay, so this is okay. Our regular period for sine is 2 pi. So the way you're going to do this, okay, if you go by the book, you're going to say this is 2 pi over b, and whatever number's in front of the x, that's your b. So this is going to be pi over, or 2 pi rather, over 2. It's our b. So our period for this function y is equal to sine of 2x. Our period is going to be pi. Okay, so what it does is that it's shrinking down the sine value. Okay, so let's go ahead and take a look. Okay, so this is y is equal to sine x. Okay, scroll out so we can get some seeing here. And then we'll have y is equal to sine of 2x. Not sine of 2, just sine of 2x. Okay, so look at the purple line, and it takes all of 2 pi, right? That's 6.28 or something. So it takes all of, right? It takes all of this time to get one waveform. Now look at the black line where it takes half of that time, right? At pi, we're done, okay? So it took half the time, it took half the space to make a wavelength, okay? So it is shrinking. Okay, if we do this, add a slider for b, and we go with 0, let's go 5, okay? So what's going to happen with b is if I make it larger, right? B is getting bigger, so the number in front, like here's 2, right? Notice what's happening is that we are shrinking, we're squeezing in the sine value. Okay, that's what happens with horizontal. Okay, is that this is a horizontal compression. If we go between 0 and 1, okay, so let's go back to 1. Okay, that's our regular sine. Then it's going to spread out a little bit more. Okay, it's going to spread out a bit more. Okay, so again, here's 1. Okay, close to 1. And if I slide it down, see it's going to get bigger and bigger and bigger. Right? It's spreading out. Okay, the maximum is still at 1. Okay, maximum is still at 1. Okay, but so the range the range of the function is not changing. Okay, the y values don't change. Okay, but they're just being spread out. And again, when we get back to 1 and we push it forward, it's going to look like it's squeezing in. Again, the range, how high and small it is not changing. Okay, it's a little bit different with polynomials. Polynomials, it was hard to tell. Okay, with trig functions, there is a definite difference of horizontal stuff stays as horizontal stuff, and vertical stuff stays as vertical stuff. Okay. If you remember, let me do this for a second. If you remember back in college algebra, we did something like y is equal to a square root of bx. Okay. Oops. So look what happens with b. Okay, I'm raising the inside one. And it almost looks like I'm raising and lowering it. Same thing is going to happen here. Okay, same thing is going to happen here. If I'm on the outside, it looks like I'm raising or lowering. What's technically happening with the B part is I'm shrinking or expanding it, okay? But what's happening in this one is I'm stretching or compressing it. Okay, but with sine and cosine, like horizontal stuff and vertical stuff is there's a very distinct difference in what's going on with it. Okay. So the other thing that I do, so sometimes this gets a little complicated, or I forget, and I need a way to figure it out. So what are my regular anchor points? My anchor points are 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? So what we're going to do here is we're going to say 2x equals 0. What's x? Let's go to the last point. 2x equals 2 pi. Solve for x. X is equal to pi. So I know where my beginning is. I know where my end is. When we get a little bit harder, we're going to put a phase shift in here. If you forget, like, oh, what's that going to do? If you subtract these, you get the period. You get one wavelength. That's one period. So if they ask you what the period is, we're going to say, well, it's pi divided pi minus 0. That's pi. We're good. All right? So period of x is pi. Right? Period of 2 pi x. Okay, so one way to do it would just be to say period equals 2 pi divided by what's b? B was also 2 pi. So the period's equal to 1. Okay, if you don't remember this formula, and that's that's completely understandable. So we're going to get 0, pi over 2, pi, 3 pi over 2, 2 pi. We have sine of what? 2 pi x. So we're going to say 2 pi x equals 0. X is equal to 0. Okay. We're going to get 2 pi x equals 2 pi. Here we're going to say x, right, divide both sides by 2 pi. We get x equals 1. So here I know my period starts at, the sine wave starts at 0 and ends at 1. So instead of calling this 2 pi, I'm just going to call this 1. This would be a half. This would be a quarter. This would be 3/4. And I'd be able to graph my function here. Okay, so that's how we graph these things by hand. Okay, but if you need a real picture, Desmos, graphing calculator, MATLAB, dozen of other things. So period here is 1. Okay, no pi's, just 1. Okay, so how about this one? This is sine of negative 2/3 x. Okay, so what this is going to do is it's going to flip it in a horizontal way, isn't it? Okay, so we're going to still say, here's my 2 pi over b. Okay, sine over 2 pi over what we have here, 2/3. So we could say 2 pi divided by negative 2/3, which is 2 pi times negative 3/2. Okay, so we're going to get a negative 3 pi. So the graph is going to start at negative 3 pi. Actually, the period is going to be negative 3 pi. Okay, so what we're going to do is we're still going to write down our anchor points. We're going to say 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right? And now we're going to say negative 2/3 x equals 0. What's x have to be? X has to be 0. If I go down here, right, we have negative 2/3 x equals 2 pi. 2 pi. We are going to have x equals negative 2x, rather. Negative 2x equals 6 pi. Right, multiply both sides by 3. Okay, and then divide by negative 2, and x is going to be negative 3 pi. Okay, so my beginning is still x equals 0. My ending is negative 3 pi. So if I was going to graph this, okay, and again, half of it, half of these two, half of these two. Okay, so it's negative 3 pi over 4. Okay. How do I do this? This is 6 plus 3 is 9. So 6 pi over 2, what's that equal to? It's equal to 3 pi. So now I can average these, can't I? I could say 6 halves plus 3, negative 6 halves. What's between negative 6 halves and negative 3 halves, right? And that's going to be negative 9, because we're adding them together, pi over 4. All right. Is this a sine or a cosine? It's a sine. All right. So same idea. All right. So period is going to be, I'm going to say 3 pi because it's a distance, and distances should be positive. But I'm open to the fact that maybe they're going to claim it's negative because they want a direction in there. They want some more context. So I'll say 3 pi. But I'm not going to be surprised if they mark me wrong. They didn't. Okay. All right. Okay, let's take this one a little bit slower. Okay, we want to know amplitude and period. So if we were going to graph this, okay, we have y is equal to what? Y is equal to 6 sine of 4x. Okay, so we have an amplitude thing going on here. We have a period thing going on here. All right. So why don't we go ahead? We're going to write down our little anchor points here. So we're going to say 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is where we start. Okay. So we're going to say 4x equals 0. What's x have to be? Right? X has to be 0. What about for the last point? We have 4x equals 2 pi. Okay. What's x have to be here? X has to be pi over 2. Okay. What if I didn't want to go through all of that other stuff, right? I just wanted to do it this way. I want to say this is 4x equals pi. X is equal to pi over 4. Okay. Now you could say, well, what's halfway between 0 and pi over 2? Obviously, it's pi over 4. Maybe it wasn't that obvious for you. Okay, but this is another way to get it. What's 3/4? What's 3 halves of the way? Okay, so we're going to say 4x equals 3 halves pi. 3 halves pi. Divide both sides by 4, and we get x is equal to 3 pi over 8. 4 times 2. Okay, or 4x equals pi over 2. Divide, we get x equals pi over 8. Okay, so when I want to go to graph this thing, right, my one waveform takes place between 0 and pi over 2. We could also say that this is 4 pi over 8, and then we have 1 pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. It might be easier to do that. Okay, halfway between, right, we get pi over 4, which is really 2 pi over 8. Okay, here we have pi over 8 from right here, 3 pi over 8. All right, and we were going up to 6, so let's call this positive 6. Let's call that negative 6. And we're graphing sine. So we start with sine, up to 1, down to 0, back over here, and then back up to 0. So we're going to go ahead and graph it this way. Right? And that's what our graph is going to look like. So if they come back and say, hey, we'd really like for you to graph this thing, we can. But for now, like, what's our amplitude? Well, what's the number in front? Number in front, 6. What's our period? So we could say it's 2 pi over, right, over 4, because that's what our formula says, which means it's pi over 2. But we could also, like maybe you forgot, we could say, well, we're going to start at 0 and we're going to finish at pi over 2. So we could say this is pi over 2 minus 0. So the period could also be found by subtracting the first and the last number, okay, and getting it that way. Okay? So identify the amplitude and the period. All right, amplitude was 6. Okay. And the period is pi over 2. It doesn't matter how you got it. Okay, you got the same answer either way, pi over 2. Okay, now we're going to graph it, and we want these values to be here. Fortunately, we already have some values. Oh, look at that. They gave us eighths, 1/8, 2/8, 3/8, and 4/8. Oh, they were so kind to us. So what we have to do is go through and do that. So we're just going to plot some points. 0, up here at 6, down here at 0, down here at -6, and then back up to 0. All right. And that's what our graph is going to be. Okay. So there's our graph. Okay, on your quiz, you're going to have to do this on your own. Okay, they're not going to tell you these are the points. So as you're doing this on your own, figure out how you want to do this. Okay, so there we go. All right. So same idea, right? 6 instead of let's do this one because it's a fraction and it looks intimidating. All right, so this is 6 sine pi over 3 x. Okay, and then we'll do that. Okay, so our amplitude is 6. Okay, our period is 2 pi over b. 2 pi divided by, what's b? B is pi over 3. Okay, how do we deal with the fraction? We invert and multiply, right? So the pi's cancel, and we get 2 times 3 is equal to 6. All right. What if you were anticipating having to graph this? You say, I'm going to need some points here. Let's write down our original points as 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right. So we have pi over 3 x equals 0. Solve for x equals 0. We have pi over 3 x equals pi over 2. X is equal to 3 over pi times pi over 2, right? We just invert, right? 3 over pi, we'll make that a 1, 3 over pi. So we invert and multiply. So this is going to be 3 over 2. Okay, here we have pi over 3x equals pi. Okay, so x is equal to 3 over pi times pi over 1. We get 3. Okay, we have pi over 3x equals 3 pi over 2. So x is equal to 3 over pi times 3 pi over 2. The pi's cancel, and we get what? We get 9 over 2. No pi's anymore. Okay? We can call this 6 pi, or 6 over 2. Instead of 3, we can call it 6 over 2. Why do I want to do that? Well, 0, 3, 6, 9. You want to bet the next one's going to be 12. Okay, 12 over 2. So this is pi over 3 x equals 2 pi. X equals 3 over pi times 2 pi. The pi's cancel. We get x equals 6, right? Which is equal to 12 over 2. Okay, so 3, 6, 9, 12 over 2. That's how we can graph this thing. Okay, we go back and say, okay, it's 6. So no negatives, so we'll just do this. Okay, we're going to go from 0 to 6. Here's 3. Here's 3 halves. Here is 9 halves, right? 6 plus 3 is 9. 9 divided by 2. Okay, and then we're going to go up here with 6. We're going to go down here at -6. And we're going to plot our points. Okay. So let's go ahead and graph. right? And then we'll see, okay? So amplitude, period, okay, the amplitude is 6. Okay, check answer. Okay, the period was 6. All right, and then we're going to graph the function. So we're going from 0 to 6, right? So let's go ahead and do this. So we'll say 0, and then halfway between here, right, we're going to be up here at 6. Can I get halfway between? They won't let me do halfway between, will they? So here we're at 0, here we're at 0. But they won't, the cursor won't let me do halfway between. So what we're going to have to do, say we're at 3/2, when x equals 3/2, we're going to be at 1. Okay, so here we go. We have 3/2. Oops, 1/2. And 1. I'll put that x will do something. Okay, plot point. And then we're going to have 9/2 at, oops, it's not -1. It's -6, isn't it? Okay. Let me, I did that. Okay. It was probably there the whole time, wasn't it? Okay. So here we go. It's 3/2 and then a +6 because that was my amplitude. All right. Double checking. Yeah. So we got to go from, there we go, x. Let's go ahead and draw that in. Okay. Just click it, it'll draw it. Check our answer. All right. And there we go. All right. So be careful about, talk about period, phase shift. Okay, if you forget, like it's supposed to be 2 pi, you can always just write down your beginning and your ending points, your basic, like here are the points I always graph. And then how do I adjust them to fit this graph? Okay. So let's see here. I think we did what? We did 3 to 9. That's about 6, 7 problems. Let's go ahead. We're not going to do this one. All right. This is a good problem. I like this one. So I'll tell you what. This has been long enough, so we'll go ahead and stop. Right. And then next video, we'll start off with number 11 because this is a good problem. All right. Take care. I'll be back in a minute.